So I'm going to have a quick video tonight where we just answer a simple question. And the question is, why bond? So far we've talked a lot about atoms. We've talked about things like hydrogen and oxygen and sulfur. But we haven't really talked about how they interact with each other. And so we know that things don't just exist as hydrogen, oxygen, and sulfur. There's molecules out there where we can have things like H2SO4. And so we combine those three different elements together in different ratios to get different substances. So why is it that elements choose to bond with each other or to bond with themselves? Why don't they just exist singularly? And the reason for that is electrons. But not just any electrons, the valence electrons. And remember, valence electrons are the electrons that are in the outermost row. So as electrons on the outsides, that's where the bonding happens, and those are the ones that decide how an element is going to bond. So let's think about when we talked about electron configurations. So remember, we always had some principal quantum number, so this would be any energy level, so 2, 3, 4, 5, whatever it is, and then the S, and then the three different P's that there was. So an element might not have all of these filled up. So if we think about an element like oxygen, we have 2 in the 2s, and then 4 in the 2p. So oxygen is not happy like this, and the reason it's not happy like this is because it has these 2 empty spots right there. This is like a hotel where they want to have as many borders in there as possible, and so oxygen wants to get those last 2 rooms filled with more borders. And so it's going to do that by bringing in 2 more valence electrons to fill in those spots. And once that is done, it now has the valence electron configuration of NS2 NP6, and I'm just using N to represent any principal number, so that's the outer row, whatever it is. So now it has 2 in the S and 6 in the P. Now it has a full outer shell, and who does it look like? Yeah, it looks like a noble gas. And that's significant because the noble gases, they don't bond. The reason they don't bond is because they're already stable. They've got enough valence electrons. They don't need any more. And so elements all bond in order to get electron configurations just like the noble gases. The noble gases are their role model, and so they bond to fill the shoes of their role model. The term that we use for this is the octet rule. So the octet rule says that all atoms want to have 8 valence electrons. So 8 electrons in their outermost row, and that will give them this S2P6 configuration and make them look like noble gases. However, there are a couple exceptions to that. First and foremost, which is helium. That's a noble gas, and it's already stable, and it only has 2 valence electrons. And it's happy with just those 2. And the other exceptions are hydrogen, lithium, and beryllium. Hydrogen, lithium, and beryllium, they all don't want 8. It would mean getting too many, so instead they want to be like hydrogen or helium, which means they only want 2 valence electrons. Other than that, for the most part, all other atoms want to have 8 valence electrons. But how do they do that? How do they get more valence electrons? Can they go to the local store and buy 2 more valence electrons to fill in their empty orbitals? No, sir, they cannot. They've got to do it by other means. So how do they get those valence electrons? Well, they steal, they dump, and they share. We are going to get into some electron drama here for a while. So when we talk about bonding, there's a lot of action going on. So atoms will steal, they will dump, and they will share their valence electrons in order to get that octet that they so desire. Now we'll talk about all of these more in depth as we go through the unit, but we're just going to get some definitions out of the way, some names. So when elements share electrons, we call that covalent. So those would form covalent bonds then. And when elements steal and dump, and that's actually a joined thing because one element's going to steal and the other one's going to dump, we call that an ionic bond. So we'll go through and we'll talk about each of these different types of bonds. And there's actually types of bonds within those types of bonds. We'll learn how to name them, we'll learn why they occur, and we'll learn about reactions that happen because of these different bonds.